Sorry about that before. I had a bit of a hot mic situation. Yeah, so look, Wi-Fi and internet, what are we going to do, Des?
Yeah, I know, this connection's not too hot today. I mean, what if there was something that we could use instead of this Wi-Fi? Maybe Richard has...
I think Richard Myers from GoTenna will have some ideas to share with us.
Yeah, I think he can probably help us out. Welcome, Richard.
Incentivizing Mobile Mesh Networks.
Yes, Incentivizing Mobile Mesh Networks.
Thanks a lot. Thanks. Okay, hi everyone. I'm Richard Myers. I work for a company called GoTenna. GoTenna makes protocols for mobile mesh networks, which enable a decentralized bottom-up communication system. And the emphasis there is on protocols. So I think it's, we've got a lot in common here with Lightning already. What I'm going to talk to you about today is an initiative that we started earlier this year called Global Mesh Labs. There we go. So first I just want to point out that over the last less than 2 years, we've seen an explosion of apps that take advantage of really the core features of Lightning, which are fast, permissionless payments. And that's very natural. That's what we expect. But we've also seen some really interesting applications come out that leverage the sort of permissionless aspect of Lightning for communication specifically. So obviously there's Satoshi's Place, where you're paying with Lightning channels, and the BlockSat transmission satellite, and also YAWL. So these are examples of taking advantage of the fact that it's a private and permissionless payment to communicate. And another interesting thing that if you've been up on the second layer, and if you haven't, you should go check out, is how Lightning has been embedded in hardware devices, and how some of these devices actually allow you to do Lightning payments not just from an embedded system, but also in a sort of off-grid system. So maybe without a direct internet connection. So the application I want to talk to you about today for Lightning is one that combines these three elements of both low-cost and fast micropayments and permissionless communication, along with embedding these concepts in a hardware device that can operate in an off-grid scenario or without direct connectivity to the internet or the blockchain. So why do we, and sorry, go back there, and that application is communication. So to pay for communication using the Lightning Network in a decentralized off-grid manner from a mobile mesh network. So why do we need an alternative communication system? Currently, the communication systems we use are very centralized, and in most places, they're controlled by a very small number of monopoly companies. And these are merging. These companies are merging all the time, so we're getting fewer and fewer choices for communication. And in many parts of the world, the communication just to get access to the internet or even sending SMSs is either very difficult to get or is a very significant portion of somebody's salary. So having alternatives to the centralized communication infrastructure and perhaps ways for people to share the communication infrastructure they do have access to is an important way to get the benefits of the internet to reach more people. And also, even in highly developed countries, Hurricane Sandy was a good example in 2012. Centralized systems are not very resilient, and that's a very strong argument for decentralization. And Bitcoin, Lightning in general, is that it can create more resilient systems. And it's not just resilience against storms; it's resilience against censorship. And this is something that we see playing out more and more, not just countries like China, but even, ostensibly modern democracies like Spain, shockingly invoking censorship when there is a political crisis. And now there's discussion of this happening in the legislature of Hong Kong too. So obviously censorship is a very big problem, and that's something that's very easy to do with a centralized network. There's one central point that you can turn the internet off. And by, we're looking at wanting to do a more decentralized system, there won't be that central off switch for the internet or communication in general. And obviously, privacy is a big factor, and surveillance is something that's now been, pretty well disclosed. And even the chancellor of the country of Germany was not safe in her privacy. So, if she's not, then obviously the rest of us are in a lot of trouble. And that's something that's, again, easy to do from a centralized network. There's a centralized place to tap. Historically, mesh networks have been proposed as an alternative system for that, and starting mostly with the military and governments as a way to, to get around at least some of the surveillance and security issues associated with centralized communication. But there's never been a consumer product until now. I'll show you. This is a GoTenna mesh. It's a device that pairs with your mobile phone, and it allows you to communicate peer-to-peer in a totally decentralized network. So that means no Wi-Fi, no satellite, no Bluetooth required to communicate to somebody else. The way this works is if the person you want to communicate with is in range, then your device will send a message to them. And if they're not within range, then it'll hop from device to device to device until it reaches the person that the message is supposed to go to. So what this allows you to do is basically turn density into a form of infrastructure and create a bottom-up network for communication. So the other thing, so the other interesting thing about mesh networks, and this is another way it's a little bit like Bitcoin, is, so this is a map I have up here of government's attitudes, regulatory attitudes towards Bitcoin. And you see this, and it does have some influence perhaps, but it's also not something that really matters. I mean, Bitcoin is a protocol. It's not something that you can, being a protocol, it isn't something that can be easily censored or shut down by going after some central company like a PayPal or a Visa network. And the same is true with a mesh network based on a protocol. Is it's something that can actually grow to become a global protocol without having to negotiate the individual regulations of every single country, just like Bitcoin didn't have to negotiate the individual financial regulations of every country. So again, mesh networks have some similarities and share some advantages. But there's a problem with any sort of peer-to-peer network, and that is, how do you bootstrap the system from a small number to a critical mass of people that can be useful? Because without a critical mass of people, these networks aren't too useful. Something like the internet was bootstrapped by a government, but how do we actually bootstrap something that's decentralized, that doesn't have a central owner? This is where Bitcoin showed that a protocol could, in fact, incentivize its own use. And in this way, grow its peer-to-peer, grow to be a large peer-to-peer network without a centralized organization essentially building the infrastructure for the network. And we'd like to do the same thing for mesh networking. We'd like to take the same properties of the Bitcoin network of being decentralized, permissionless, and sort of distributed and resilient, and apply that to communication. So we could just use Bitcoin as it is, but obviously there's some problems with that, and that a few of the problems are that Bitcoin doesn't really scale to a lot of small micropayments, and that's just the nature of Bitcoin. But it's also not good for our particular use, which is an off-grid use. You would have to validate on-grid every single payment you receive, and that's not gonna work really well for mesh communication, because if you have that communication, you wouldn't need the mesh to begin with. So you probably figured out my next slide here. Lightning fixes this. Lightning has the ability to do many small micropayments for low fees, fast without waiting for long block confirmations. And it can go off grid for a certain amount of time before it has to actually touch bases and check that a payment is valid. But we don't want to rewrite the Lightning protocol for our specific use case, of global communication. You know, it's optimized for payments. It's not optimized for communication per se. So we're developing a protocol we call Lot49, which uses a lot of the same ideas from Lightning, but instead is adapted specifically for communication purposes. And the way it works is, you can imagine if I'm sending a piece of data, I'm going to attach a pre-image. This is a lot like the extra onion blob protocols that has already been discussed with Lightning. But so it's going to take your message and your pre-image, encrypt that, and it's going to send it from peer to peer to peer. And each peer along the way is going to be able to collect a payment, a Lightning payment, using the payment information that's attached. When the message is received at its destination and is unwrapped, then that can flow back, and the nodes that were involved in relaying your message will get rewarded. This is the basic Lightning payment protocol. And in this way, we achieve sort of two things in particular. One is we create an incentive for people to run nodes to relay messages where and when they're needed. But we also have created a system there so that you can fairly share the resources of the network, because you're going to be using people's battery and their antennas essentially to relay your data for you. So having a Lightning payment is a way to sort of fairly allocate that shared resource. And we have some other constraints that you don't have with the standard Lightning model as we envision it now, mostly to do with the fact that we're dealing with a radio-based mesh network. And that's because you've got a trade-off between the cost of the device that you're relaying, how much power it takes, and batteries run down as you relay messages, and how much bandwidth. And bandwidth is the one that's probably the most important consideration in our design of Lot 49. There's a lot of different mechanisms you can use to create a mesh network. But they all have these trade-offs about how long range they can broadcast, how much power it's going to take of each mobile unit to broadcast that data, what's the bandwidth, and and whether they're in some of these protocols aren't necessarily even set up for meshing. They're more point-to-point protocols. But for us, it's really we figure if we can optimize for the lowest bandwidth possible, much lower than the internet, then it has the same effect as creating making Bitcoin nodes sort of having the lowest resources possible. By reducing the resources we need for both bandwidth, power, cost, we can increase the ability of people to run nodes and increase the size of the network by making the resource demands low to be a participant in the mesh network. The common theme, though, that we do share with what we're doing and the Lightning network as it exists is this idea of an HTLC. The parts that we are changing, the areas that, so if you look at Lightning and the different bolts, we really would like to, as much as we can, leverage what's been done in Lightning. But where we would want to change things are in the messaging, the communication and negotiation between nodes, and the routing potentially. Those are both areas that aren't really critical to the idea of an HTLC-based payment network, bidirectional payment network, and can be adapted to our particular use case of making a communication application. So we're coming at this from two different directions. The first direction is taking Lightning as it exists today and taking Bitcoin as it exists today, and looking at how we can, for example, suppress gossip or do trampoline payments, and then for receiving off-grid information about the blockchain, using things like block digests and creating, like using block headers as a way to do more of a light client for the mesh node so that they don't have to receive the high bandwidth blockchain. A few other places where the protocol would need to change, or sort of the contracts, the HTLC contracts would have to change a bit, are primarily around timing. So we're dealing with a slower network, a lower bandwidth network. So your HTLC timeouts would also have to be longer. And that also would, because you're not online in a synchronous way, your timeouts would also have to be longer to give you more time to detect if a channel's been closed and you want to collect your penalty potentially. Also, our communication with the network being off-grid means we're going to have to go through relays. So, currently our model is that there would be that your nodes themselves wouldn't necessarily be full nodes, but you would be going through gateways in order to access that information. And that data and those requests and return data about the state of the blockchain is something that would have to come back through relays. So this puts a little more demand on the network. Our current proposal right now, our current implementation right now, you can actually see, I guess after my talk up in room 2, Will Clark is going to show a demo where we've managed to take a version of Seed Lightning and make some changes to suppress gossip and increase some timeouts within the code and actually negotiate the update of a channel with new HTLCs using the mesh network, so using a simple version of the mesh network. So you should go see that demo if you're interested in this stuff. So that's the first checkbox there. But the next steps for us in that direction is to be able to set up channels off-grid, to do that through the mesh network, and also to send data and pre-images along with our messages. And then delegating routing, so doing a different routing system. In our case, it would be probably using the native mesh routing that Gotenna has, but other devices might use a different system. The other direction is to basically look at Bitcoin as it could be, look at Bitcoin using soft forks that we think could help us with low bandwidth. And I think the most important one is the no input soft fork that would allow us to do L2. And with L2, we believe instead of using 1.5 round trips to negotiate an update, we could actually do it in as little as a single transmission to do a payment. And that doesn't just save us bandwidth, but also if you're looking with high latency communication like satellites, having a single message can really speed the process of making these payments. Also, watchtowers, using L2 would allow us to not have to send every update to a watchtower, and especially with long delays, we could send periodic updates of channel updates to a watchtower, which is going to be off-grid somewhere, in order to monitor our channels. Also, Taproot, that just makes our setup transactions much smaller, but because we're going through a gateway, it's important that any savings that would actually help us on the blockchain, it also helps us in transmission over the network, so that we don't overload the net, we don't like add extra data transmission just to set up our channels over the mesh. Also, just Taproot in general allows us to do things with Merkle trees so that we can amortize the cost of our payments over multiple data messages. And that could have a big impact in sort of increasing the data over the network that's being used for messages and minimize the data that's being used for payments. Also, channel factories, that gives us the opportunity, that was mentioned earlier, but channel factories means that if we had L2, if we had the no input, we could open and close channels without actually going through a gateway to the internet. So that's an important aspect of how to do this in a low bandwidth way. We also think there's some tricks we might be able to do with signatures, so we could save 25% potentially by sharing ours. We're still working on that. We're simulating all this first to try to make sure that we get the right protocol trade-offs. Oops, clicker's not clicking here. There we go. And just important to mention, this is a completely open source project. Both the protocol and all of our reference implementations are open source, and we're very actively interested in getting this protocol to run not just on the Gotenna units, but to do it over satellite, to do it over LoRa, to do it over Wi-Fi, Bluetooth, everything that's out there. Because we really want this to be something that can bootstrap a global network over any sort of network. And we're looking for people to help us. So if you are interested in making Lightning applications that are off-grid, we'd like to talk to you. If you have your own interest of a particular piece of mesh hardware. I think we're going to hear about one next. We would like to run Lot 49 on your hardware and just make sure that we can cross and have gateways between these networks. And if you have a particular use case, something that would benefit from having peer-to-peer mesh communication, please talk to us, because this is something also that could give us good information about how people will use these mesh networks that are incentivized by a payment on a Lightning Network. That's it. Thank you.